Okay, so these are three questions that interest me. Can logic be revised? If so, can it be revised rationally? If so, how? Okay, so those are the three questions that interest me. And as I said, a lot has been spoken and written about this in the last 30 years, and I think a lot of it is rather confused. And I think much of the confusion arises because there are several different senses of the word logic going on here. And once you disentangle the various different senses of the word logic, I think a lot of answers to these questions become fairly patent. Okay? That's not the case with all of them. But at least disentangling the various different senses of the word logic is necessary before you get to the real issues. Okay, so the word logic is highly ambiguous, and let me set one ambiguity on the surface just to set it aside. Logic can be deductive logic, or it can be non-deductive, inductive logic. Okay? Let me make it plain that I'm talking about deductive logic in this talk. That's not because I think that inductive logic is uninteresting, it's just that you can't talk about everything at once. I think, as a matter of fact, that the sorts of things I will say about deductive logic carry over into inductive logic, but that will be a whole other issue. All right, so having set aside that disambiguation, there are three more which are going to concern us. These are as follows: logica docens, logica utens, and logica ens. And I'll explain more what these are when we get to them. But if you know your Latin, you will know roughly what these mean. Logica docens is the logic we teach. Okay? Logica utens is the logic we use. And this distinction is medieval. It's also in Peirce. The third one is logic ens. That's logic itself. It's not clear what that is. We'll come back to that. I made up this name because I didn't know a nice medieval name for it. Okay, but it's the logic we teach, logic use, and logic itself. So, as I say, I'll explain more about what these things are when we get there. However, for each of these three senses of logic, there are three corresponding questions. So the structure of the talk is as follows. I'm going to run through these three senses of logic, and for each of these, I'm going to ask these three questions. And in fact, I'm going to spend most time on this. That's not because it's the most important. I think this is the most important. However, the situation here is clearer, and a lot of the preliminary discussions of these spins off this. So I'm going to spend most time talking about this, but I'll get to these two, which I think are actually more important in the end. Okay, so let's start with logica docens. And what do I mean by this? Well, it's the logic we teach. That is, the logic that you will find in textbooks. So, yesterday, Michael distinguished between logic 1, logic 2, logic 3. This is very close to this distinction, but I don't think what I mean by logica docens is exactly what he meant by logic 1, because there's another disambiguation of logic which is necessary. That is between pure logic and applied logic. And if that distinction is not clear to you, just think about geometry for a moment. There are many pure geometries, Euclidean, Riemannian, blah, blah, blah. And as pure mathematical structures, they're all perfectly fine. There's nothing to choose between them. Okay? They're all, well, some are more interesting than others, but that's a different matter. But of course, geometries have applications. So you can apply geometry for many different purposes. But geometry was coeval with what I would call a canonical application, namely charting the spatio-temporal structure of the cosmos. In fact, in Euclid, the canonical application and the geometry itself aren't clearly separated. But conceptually, you need to separate them, because after the rise of non-Euclidean geometry, then the question of what was the correct geometry for the canonical application becomes a crucial question. All right, now, what I mean by logic is logic with its canonical application. So there are many pure logics. You'll find some of these in textbooks, there's various substructural logics and so on and so forth. But logic, like geometry, has a canonical application. And the canonical application is not charting the spatio-temporal structure of the cosmos, but charting the structure, let me leave it at that for a moment, I'll come back to it, of reasoning. Okay? So you can use logic to test for grammaticality, to simplify electronic circuits and so on. These are perfectly fine applications, but these are not the canonical application. So I'm interested in logic. Logica docens is logic with its canonical application, namely getting right how to reason, how the right moves to make when we infer. Okay, so that's what I mean by logica docens. Now, can it be revised? Well, this is a no-brainer. Okay? Read the Organon, read Paul's Logica Magna, read Kant's Logic, read Hilbert Bonnier's Grundlagen. They're different. Okay? It's clear that logic we teach has been revised in the West over 2,500 years. Okay? So this is not an interesting answer. Yeah, I might want to say, hey, yeah, but the way it's been revised ain't terribly interesting. Kant thought that logic hadn't been revised in 2,000 years. That was kind of just a matter of ignorance. But you might think, well, it has been revised a little bit, but only cumulatively. Aristotle got a bit right, and then maybe Leibniz put on a bit more, and then Frege put in a bit more. So it's all kind of cumulative. And this is just not true. Okay? As logic has been revised, logica docens has been revised, things come and things go. Okay, let me give you a couple of examples of that. This is an inference called dirapti. Okay? It's a valid Aristotelian mood of the syllogism. It was accepted as valid by anyone who endorsed syllogistic. So this is the medievals, the people in the 19th century, before the rise of mathematical logic. All A's are C's, all B's are C's, therefore some B's are C's. Okay, they all thought this was valid. I mean, okay, write it in predicate calculus, you'll see that it isn't. Okay? Of course, there are fiddles and tweaks you can do, but, I mean, if we start talking about the fiddles and tweaks...
In case anyone knows, that's not dirapti.
Isn't it? What is it, Steve?
All C's are A's, all C's are B's.
Oh, okay. I've got the mood right.
That's invalid.
Sorry?
That's simply invalid.
Oh, bugger, thank you. Right.
No, all C's are B's.
Oh.
No, C's.
How about that?
No.
No? Hang on, let's get this right.
All C's are B's. All C's are A's. So all A's are, so some A's are B's.
Thank you.
Is that right?
Yep. Okay, so that's dirapti, okay? And that's not valid in modern logic, but it's a valid mode of the syllogism. All right. So that's something that people thought was valid, and we now no longer think it's valid. That's a loss, okay? Let me give you another example. Explosion. Okay. This is inferring an arbitrary conclusion from a contradiction. Paraconsistent logic is one where you can't infer an arbitrary conclusion from a contradiction. Okay. Consider this syllogism. Yeah? I know it's got only two terms, but Aristotle said that's fine, you can repeat a term. Some A's are B's, no B's are A's, therefore all A's are A's. Okay? It's invalid. It's not a valid mood of a syllogism, but the premises are inconsistent. Okay, so people working in the syllogistic tradition were working with a paraconsistent logic. So logic in ancient Greece is paraconsistent, logic in the 19th century is paraconsistent. Where did the idea that contradictions imply everything come from in the history of philosophy? Well, the earliest reference I know is in Paris in the 12th century, where a logician called William Soissons discovered or invented the argument we now call Lewis independent argument or Duns Scotus argument or the argument for explosion. Okay? And then that was used by some people in the Middle Ages and then got quietly forgotten after the demise of logic and the rise of humanism. So, things come and things go in the history of the logic we teach. There is no cumulative progress. Okay, so does logica docens change? Yes, certainly. Does it change in a cumulative fashion? No. Okay, so let's move on to the second question. Logic can be revised. Now, can it be revised rationally? Well, if you look at the history of logic, then it seems pretty clear that revisions weren't always rational. So there have been three great periods in the history of Western logic: ancient Greece, the medieval universities, and late 19th and later century. And sometimes what happens is stuff gets forgotten. Okay? So with the rise of humanism in the 15th, 16th century, the great advances of medieval logic were all forgotten. And all that people could remember after that was the kind of Bowdlerized form of traditional logic that you get in Kant's logic, for example. So I don't think this was a rational change. It's just that scholasticism fell out of favour, and the logic just fell into oblivion because of that. So sometimes the changes in the history of logica docens have not been for rational reasons. Okay, but it beggars belief to suppose that all the changes that have occurred for merely sociological reasons of this kind. So, for example, the change that we know most about, I guess, is the change that gives rise to classical logic around the end of the 19th century, beginning of the 20th century. So, traditional logic, that is the logic you find in textbooks in the 19th century, was replaced by the logic of Frege and Russell. Okay. Did this happen for sociological reasons? Was it just that Aristotle fell out of favour? Well, you'd better think not, okay? Because most of you here will think that mathematical logic was a great advance on traditional logic. And I think that's right, okay? Why? Well, I'll come back to that in a second. But it's clear that logica docens is revised rationally sometimes, okay? So that's the answer to the second question. So, how? Okay, and for once in my life, I find myself largely on the same page as Tim on this issue, which is kind of scary, but hey. What is the logica docens? Well, it has a canonical application, namely the canons of reasoning, or the norms of reasoning, or how to reason correctly, and every logica docens is effectively a theory of the correct norms of reasoning, or the correct ways to reason. Okay? So if you look at intuitionistic logic, it will tell you one story about the correct norms of reasoning. If you look at classical logic, it will tell you another. Each of those gives you, in a certain sense, a theory of the correct way to proceed when you reason. Okay, what is the theory a theory of, more precisely? Well, I'm glad to say that here I do disagree with Tim, because he explicitly distanced himself from the thought that theory is about a theory of validity. Okay, for me, a logica docens is centrally a theory of validity. So when we reason in mathematics, we reason in law, we reason in science, because we don't reason in formal languages. No one reasons in formal languages. We reason in vernaculars. But we make inferences. You know, we look at the consequence of our views and see whether they're right or wrong. And validity is the core notion here. Okay? When you give a theory of validity, a logica docens, what you're trying to do is get the story about validity right. What follows from what? And more importantly, why? Okay. Now, this is no mean undertaking. Because, okay, although validity is the core notion you're looking at, a lot of other things are going to get in on the ride. So, for example, it's going to be, in practice, impossible to talk about validity without talking about conditionals, without talking about negation. And when you give an account of validity, it's not clear what else is going to get in on the act. Do you have to talk about truth? Do you have to talk about meaning? Do you have to talk about probability? Well, plausibly, you might tell a story concerning all these. So when you construct a theory of validity, this is a large-scale project. People disagree about how you do it. They don't just disagree about what really is valid, they disagree about why it's valid. And if you look at the history of philosophy, there are several different sort of global accounts of this kind which people have constructed. So, for example, one possible way of telling this story is the theory of the syllogism, as articulated in the Middle Ages, with a suppositional account of what we now call truth conditions. Okay? So, syllogistic told you what was valid, and the theory of supposition told you why these things were valid. Another possible way you can do this is you can endorse something like classical logic and give a tasking account, a model theoretic account of what is of validity. That's another way you can do the project. Another way you can do the project is this. You can take intuitionistic logic and you can give an account of validity in terms of proof conditions. So you can be an inferentialist about what validity is. All right, so these are three different ways of constructing theories of validity. And I'm sure there are more. But each of them tries to give an answer to the question of, when we reason, which inferential steps are okay, which are not, and why. Okay, so logica docens is a theory. Now, how do you choose between competing theories? Well, here, I think I do agree very much with Tim. We've got all these criteria for theory choice, which we apply whenever we theorise. Okay? We theorise in metaphysics, in science, in logic, in morality, and in the end we choose the theory which is most rational, and the most rational is, I think, probably the theory that performs best on the various criteria of theory choice, things like simplicity, fruitfulness, and so on. There's a lot more to be said about this, but I won't go into the details now. And of course, one of the most crucial criteria is adequacy to the data. Okay? You want the theory which gives the best adequacy to the data that you've got. And you might say, well, what counts as data in logic? And I'll tell you. And I'm going to tell you by just looking at how you applied this account on one particular case study, which is the rise of classical logic, which we met just now. So, the revolution in logic at the end of the 19th century is driven by mathematics. Okay? 19th century is the time when mathematicians were worrying about the rigour of their subject. So they figured out what infinitesimals were, what rationals were, and so on and so forth. But they wanted to know what numbers, whole numbers were. And in the process of that, they had to look very, very carefully about the canons of correct reasoning, because the old syllogistic was just not up to the job. You couldn't do what the mathematicians were doing in syllogistic. So the data that a theory of validity had answer to just said, Aristotelian logic's hopeless. We need something which tells us more about more kinds of inferences. And so classical logic was born. And the success of classical logic over syllogistic happened within about 20 or 30 years. I mean, there was a backlash against it, of course, by the Thomists. However, it was clear that classical logic was so much better at giving an account of a lot of the inferences that get made, for example, in mathematics, that Aristotelian logic was swept away. And it was replaced by much better, much stronger theory. This is precisely a case of the replacement of one theory of validity by another one, where the theory that was the later theory was selected precisely because it was much better on most of the criteria of theory choice, and especially adequacy to the data. Now, since Tim raised this morning, let me just digress for one moment, because he seemed to think that if you look at logic in this way, it's clear that classical logic has a lot going for it, and I think it does, but he seemed to think also it's pretty obvious that it was better than any other thing going on the market. And I think we disagree about that, but that's not surprising. Classical logic does a pretty good job of accounting for the inferences that get used in classical mathematics. Let's give it that, okay? That was its home, that's where it came from. Does it do such a good job of accounting for correct reasoning in other areas? To do with paradox, to do with non-classical mathematics, to do with tense, to do with the conditional, okay? To do with vagueness. It's not at all obvious that it does such a good job of accounting for inference, for validity in those areas. And I think this is the strength of non-classical logics, where they have a strength, namely that they address some of these problems that arise when you try to apply classical logic outside its sort of standard area, as it were, and worry about other things. And I think when you start to look at that, it's not so obvious that classical logic is stronger than the other contenders. But that's a side issue, and I raise it just because I wanted to demur from what Tim said this morning. Okay. All right, so that's logic of Dawkins, okay? Can it be revised? Yes. Can it be revised rationally? Yes. If so, how? I've just told you. Okay, so that's the first issue. Let's move on to logica utens. So logica utens is the logic we use. So this is the way that people reason. Okay, it's not to do with their theory, it's to do with their practice. All right, so first thing to do here is to make sure that you understand what I mean by logica utens. Because, I might think that it has something to do with the way that people actually reason, the psychology of reasoning, okay? And this is absolutely not the case. The logica utens is not some kind of psychological theory about the way that people actually reason. Why not? Well, because we know that people reason pretty crappily. And it's not because they're drunk or asleep or whatever, but there are all these studies in psychology which show that people make these very standard and systematic mistakes. So many of you will know this, but let me just give you an example for those who don't. There's something called the Wason card test. Okay? So the Wason card test is this. You've got cards. There's a letter on one side and a number on the other. Okay? There are 4 cards face down on the table, and what you can see is this. And the Wason card test says, consider the conditional. If it's got an A on one side, it's got an odd number on the other. If it's got an A on one side, it's got an odd number on the other. Yes, you're asked, which cards do you need to turn over to check that hypothesis? So what's the minimum number of cards you can turn over to check the hypothesis? You do this test on first-year undergraduates, even ones who've done Logic 100. And a lot will say this. And a lot will say this. That's wrong, that's the right answer. Okay? I won't ask you to put up your hands how many of you got the answer right. Is it the other way around? Yeah. Okay. If it's got an A on one side, it's got, to say even or odd?
Odd, you said odd.
Sorry?
You said odd.
Odd.
So you want 4.
Thank you. Okay. Okay. Yeah, well, you have to remember whether you said odd or even in the first place. Okay, so you can do this test on undergraduates who you'd think might be reasonably cluey about this, even ones who've done Logic 100, and more people give the wrong answers than the right answers. So this is some kind of systematic mistake, and people make this kind of systematic mistake. Of course, once it's pointed out to them that there's a problem with their answer, they can recognise this. So what this illustrates is that we're not talking about the systematic ways that people actually reason, because these can be mistaken. What we're talking about is something like the norms of correct reasoning. So people have a practice, and the practice, when done correctly, will have norms. And what logica utens is the norms of the correct practice, when it's corrected by things like mistakes like the Wason card test and so on. Okay, so that's logica utens. Can it be revised? Well, yeah, prima facie it can. Okay, so, I was trained as a classical logician. I know how to reason as a classical logician. I can reason like that. I know when I've done it right, done it wrong classically, but I also know how to reason rightly or wrongly as a paraconsistent logician. I can do that as well. I can put on different hats, I can do it this way, I can do it that way. So change is possible, change on every day. You can reason as a classical logician on Mondays, Wednesdays and Fridays, an intuitionist on Tuesdays, Thursdays and Saturdays. And then Sunday, well, you can be a paraconsistent logician. Okay. So it's clear that you can have different practices and you can revise your practice at will. You might think, well, hang on, didn't Wittgenstein say that when we revise, we sort of go on in a certain way and we don't really have much choice about this? It's just how you feel forced to go on after suitable coaching. But there's the rub, after suitable coaching. So you coach someone in the ways of classical logic, they get the hang and they can go on as a classical logician. You coach someone in the ways of intuitionistic logic and they can go on as an intuitionist. Okay? So the fact that these things force themselves upon you after suitable coaching doesn't show that you can't change, because you can just change your dispositions after the appropriate coaching. Okay, so logica docens can be revised in a way I've indicated. Can it be revised rationally? Well, I suppose, I could be a relativist about this. So, intuitionistic logic is just as good as classical logic, and what I do on Mondays and Wednesdays and Fridays is equally good to what I do on Tuesdays, Thursdays and Saturdays. I don't think that really washes, because logic is not an isolated game. Logic meshes with other things we do. We use logic to reason about all kinds of things, about mathematics, about physics, about morality. And whatever you think the correct account of validity is, then truth has got to be engaged with it, okay? So you might not think that logic is simply truth preservation, but hey, if you're using a kind of inference which takes you from things which are definitely true to definitely false, something's gone seriously awry, okay? So there must be some accounts of validity that are better than others, because some are going to be pretty crappy. All right. There's an out here, I suppose, which is you can be a relativist about truth itself. And if you are, then the argument that I've given you won't be very persuasive. But I think I'm fairly safe that in this audience there aren't many postmodernists in the audience. So I'm going to just assert blankly that truth is not relative. Only one truth. And because validity engages with truth, it's got to be the case that some accounts of inference are better than others. Okay, and so presumably if some are others, then it's rational to revise your account into one that's better, if you can find one. Fine. So that's the logica utens. Can it be rationally revised? Yes. If so, how? Well, it seems to me that the most natural answer to this is as follows. How do you try to figure out what's the best practice, or the norms of the best practice? What you do is you try to figure out what the best theory is. And once you've figured out your best theory, you bring your practice into accord with that. So I think that's the way you rationally revise your logica utens. And it spins off rationally revising your logica docens. Okay. So that's the first two of our disambiguations. Now let's move to logica ens. What do I mean by logica ens? Well, it means logic, its being, logic, if you like, itself. When we are constructing a logica docens, we are constructing what is a theory of something. And the something is the logica ens. So it's what we're trying to capture when we theorize with our logica docens. So if you like, you can call this the facts about validity. Or if you don't like the word fact, you can just think of truths of the form, this follows from that, or this inference is valid. Okay. So that's what I mean by logica ens. Now, I want to ask the three questions about the logic at ends. And I think this is where it gets hard. I think most of what's gone before is relatively straightforward. Here, I think it's not. So in some sense, what's gone before was being sort of ground clearing for much harder things. So can the facts of validity themselves change? Well, in part, you cannot answer that question until you have decided on the right account of validity. Okay? Because until you know what constitutes validity, you can't even approach the question of whether that could change. So let me make that graphic. Here's one account of validity. An inference is valid if God says so. Well, given that you're not playing with a kind of God who has a sense of humour, God is constant and so on, then the facts of logic are not going to change if that's your theory of validity. Right? Here's another theory of validity. I call it the dentist theory of validity. What's valid is what 70% of dentists recommend. Okay? If that's what is valid, then clearly that can change. Okay? Now, both of those are silly accounts of validity. Doesn't matter. Because what they show, what they illustrate, is you can't answer the question of whether logic at ends can change until you are clear what validity is. Okay, so any further remarks I make are subject to that, an understanding of that question. And I'm not going to give you a systematic taxonomy of all the theories of validity you could give and run through the possibilities. That's not appropriate here. But let me just make a few comments about this. Because although there are many theories of validity out there, I think there are two dominant approaches in contemporary logic. There's a model theoretic approach and a proof theoretic approach. And of course there are others, but many logicians subscribe to one or other of these. So in a model theoretic approach, you define truth in a model, and then you define validity as truth preservation over all models. In a proof theoretic approach, you define the inferential rules which govern the various connectives, and then a valid inference is one which you can get by chaining together these rules. Okay, so let's assume that something like that is right, okay, just see where it goes. If you think about it, on either account of validity, validity is going to be tantamount to a relationship between abstract objects. Okay? So truth bearers, at least as currently conceived of normally, are kind of sentences, sentence types, abstract objects. And validity is a relationship between, well, on the model theoretic account, validity is a relationship between those and models. Models are sets, abstract objects. Okay. What about the proof theoretic approach? Well, the truth bearers or the objects of proof are sentence types again. And you define validity in terms of sequences. Sequences are abstract objects. And so, an inference is valid if you've got a sequence of the appropriate kind. Okay, so whichever of those you choose, whether or not something is valid is going to be a statement about abstract objects. And at least if you subscribe to standard views about abstracta, those cannot change. And I think that's about right. So the facts of logic, if you subscribe to one of these views, cannot change. So if the answer to 1 is no, then 2 and 3 don't materialise. I wish the answer stopped there. It doesn't, unfortunately, because things get just a little bit more complicated. On either the proof theoretic or the model theoretic account, you can think of something or other as giving meaning conditions of, the logical connectives. So you can think of truth conditions as spelling out the meaning of connective. You can think of proof conditions or the introduction of elimination rules of inferentialism as giving meaning conditions. And so maybe it's the case that the facts of validity don't change. But maybe the way you choose to express them can, okay? Because suppose you change from one theory of validity to a theory which gives different truth conditions. Then it's natural to suppose that in this new theory, the connectives or whatever have different meanings. And so you can certainly change whether an inference expressed in the old terminology was valid or not just by changing the meanings. And you might say, well, hey, well, that's kind of trivial, not very interesting, haven't changed anything much. But it's more complicated than that. Because the reason you probably think it's trivial is this. Hey, if you change their meanings, then we can just invent a new word. We don't need to fiddle with the truth conditions or proof conditions of the old concept. We've just got new truth or proof conditions. Let's have a new word and express that. And that would be nice if you could do it. But you can't always. The trouble is that meanings interact. So, for example, suppose you're an intuitionist. Suppose, we'll give negation not to the intuitionist. And someone says, well, hey, let's try a new negation with classical truth conditions. Fine, do that. All hell breaks loose. Okay? This is not a conservative extension of intuitionism. It's not conservative over the conditional part, for example. You can't simply always choose a new word to express the new truth conditions. Sometimes you're going to have to choose whether the old meanings were better than the new meanings, okay, whatever that means. Okay, but let's suppose you do think that you should revise in this way to replace a set of meanings with a newer set of meanings which are better. I'm not sure that I can make sense of this thought, but let's run with it to see where it goes. If you're sceptical about sort of the distinction between facts and meanings, you might not like this way of putting it. Sometimes people don't like talk of meanings at all, even logicians at the start of the 21st century. However, as Tim pointed out this morning, sometimes people think that words do change their meaning. Well, obviously words change their meaning, but sometimes think that words change their meaning rationally as theory develops. And this morning Tim pointed out Kuhn and Feyerabend in the 60s, the 70s, who argued that when you replace one theory with another, you are liable to get some meaning change. Now, I'm as sceptical as Tim about this. I don't think you do. I just think in general you're changing your theory of what the meanings of various particles of the vernacular are in the logic case. But if you set that aside, you might think that you can change not the facts of logic, but the way that they're expressed in our canonical languages. And that the meanings change as you change your theory for the better. Okay, and if you do think that, then you can revise logica ens, or at least the way that the facts about it are expressed. And how do you do that? Well, again, you do this in the process of choosing a better theory, a better logica docens. So I'm sceptical about the thought that the facts of logic can change, or even that it makes much sense to suppose that the way they're expressed can change in any interesting sense. However, if you do think they can for kind of Kuhnian, Feyerabendian reasons, then the answer to how they're changed and how they're rationally changed is essentially the same as before. You change your best theory, or you choose your best theory, and then you settle your utens or your ends in accord with that. Okay, well, there are lots of more to be said about all these things, but I'm sure that some of you will say those in discussion. So let me just wind up, remind you of what I've said. So what interests me are these three questions. Can logic be revised? If so, can it be revised rationally? If so, how? And as far as logica docens goes, I said yes, it's obvious that it can change. It's obvious that it can change rationally, and the way it changes rationally is by the standard criteria of theory choice. We choose one theory over another when it meets the usual criteria for one theory as being better than another, and crucially, things like adequacy to the data. Okay, can the logic of utens change? Well, yes, it can, because you can follow different practices, different norms. Can it be revised rationally? Well, it better be revisable rationally unless you're a relativist about truth. How do you do so? Well, you get your theory right and you bring your practice into line with it. Logic at ends. Can that change? Well, I think not. Because in the end, we're dealing with relationships between abstract objects, and I don't think those change. However, as I said, there's a bit more to it than that, because you might think that the facts don't change, but at least the way we express them can legitimately change. And can legitimately change maybe in ways which make some old meanings unavailable. So that's the stuff about, adding new connectives which screw up the old connectives. I mean, in some sense, if you add Boolean negation to intrinsic logic, the old meaning of the conditional becomes unavailable to you. So maybe, even if the facts of logic can't change, the way we choose to express them can, and the way we choose to express them can make meanings that were available to you before unavailable. Okay, I'm not mad keen on that view, but if it's right, then how is this rational change made? Well, it's made in the same way, by getting your theory right, and then bringing your language, not your practice on, but your language, into line with your best theory. So you determine to use words like not and or in line with the truth conditions that your logica docens gives you. Okay, so I don't pretend to have answered all the questions that I've asked. I mean, it seems to me that the answers concerning 1 and 2 are relatively straightforward. And once you've got the appropriate disambiguation, not terribly surprising. I think that this question is much harder. For me at least, this is where the main part of further debate goes, although I'm aware there's lots more to be said about all these things. But that'll do for now.